Welcome back, everyone. We're just going to continue with our review or our lecturing of endocrine system. Our last slide that we discussed, we were talking about cortisol. We mentioned that cortisol is one of the more important hormones secreted by the adrenal gland. If we scroll back up just a little bit, we can see also a little bit about aldosterone as well. But we mentioned that cortisol and aldosterone are considered these corticosteroids. So they're secreted by the adrenal cortex, because remember, the adrenal medulla, which we're going to talk more about in today's video, secretes its own hormones. So essentially, the adrenal gland has its own two separate glands overall, or two separate tissues. So the last thing we were mentioning as far as cortisol is that it is involved with many aspects of life, from the physical aspects, physiological aspects, mental health aspects. So it is a hormone that we have to be very careful with. High levels of cortisol have been directly affected and linked with like high stress and anxiety. So easy ways to deal with this: exercising and having outlets, positive outlets to calm your body down where you can. So the last thing we mentioned is that it can be useful for suppressing a little bit the immune and inflammatory response when your body's kind of in overreaction mode. All right. A lot of this here is a little bit more than we need. This is talking about how hormones work together with these glucocorticoids. We don't need to worry too much about that, but it's basically saying that a lot of these organs, like the hypothalamus, the pituitary, the adrenal cortex, are going to be working together with these other hormones to create responses, especially when it comes down to the relationship to stress. Stress is something that has been studied for years and years, because it is something that affects every single one of us very differently, and it's hard to pinpoint it. Okay, I'm just going to read through this as well. In general, steroid secreting cells have an abundant smooth. This is on the cellular level, so again, don't worry too much about the slide either. Steroid secreting cells have an abundant smooth endoplasmic reticulum. That's one of the organelles that the cells have, as opposed to a rough endoplasmic reticulum. Steroids directly diffuse across plasma membranes, abundant lipid droplets. So this is all cellular type anatomy. This is stuff that you may see in college if you pursue this stuff in the future. Okay, now we're talking about the adrenal medulla. So if the cortex was everything here, right? Everything on the outside. The medulla is all that in the yellow region there. So I'll try to highlight that just a bit. There you go, something around the lines of that, at least as close as we can get for the tools that we have. The medulla is going to be part of the autonomic nervous system. Hey, we're throwing back stuff that we learned way back in Nervous Part 2, which seems like forever ago in quarter 3. So if we remember, the autonomic nervous system is more automatic, as the name implies. These are things that happen behind the scenes more than anything else. The things that it secretes, we don't need to worry about these chromaffin cells or these postganglionic cells or neurons. The things that it secretes, we do need to worry about: epinephrine and norepinephrine. So I'm going to underline that for us, or just circle this entire bullet. So it is involved with the secretion of epinephrine and norepinephrine. That is definitely going to be more oriented to our body's fight or flight response, which we'll discuss as well. Also known as fight, flight, or fright. Okay, let's scroll down a little bit. The pineal gland. We're actually going back into the brain. This was a while back when we learned this in Nervous Part 2. And at the beginning of this endocrine system content, we mentioned that we have a very, very, very tiny gland in the brain, close to the pituitary gland, called the pineal gland. It's at the end of a short stalk on the roof of the diencephalon. So remember, the diencephalon was the structure that is going to be oriented around the the hypothalamus and the thalamus, drawing a blank a little bit there. These pinealocytes, they're going to secrete calcium particles. We don't need to worry too much about that. It can be seen on x-ray because of those calcium particles. The big thing we need to know, what we see here, is that it's involved with melatonin. That is the hormone that the pineal gland secretes. Melatonin helps to regulate your circadian rhythm. The circadian rhythm is everything that we see here in the bottom. It's a biological clock. So your circadian rhythm is not the same thing as the standard of time that we've essentially created, as far as like, oh, it is currently 11:07 a.m. in Eastern Standard Time. Um, Instead, this is more along the lines of the your body's understanding of day-night cycle. Um, your circadian rhythm can directly be affected based off of your normal sleep patterns. So something that our stay-at-home order and their virtual learning, I think something that is a very small silver lining is that for a lot of people, their sleep schedule has actually improved dramatically. I know for me at least, I'm averaging closer to like 7.5 to 8 hours a night compared to what I was previously getting of close to like 6.5 hours. If you can do that, that helps your body in many ways, as we learned when we did our sleep unit. Um, but if you do the opposite, let's say, and I know a lot of people unfortunately fall into this trap where they are sleeping, going to bed at like 3 o'clock in the morning, waking up at 4 o'clock in the afternoon. Yeah, your biological clock is very different than the outdoor time. Only when it's close to 3 o'clock in the morning do you start even feeling sleepy or tired. So it is something that definitely can be directly affected based off of your decisions and also your hormonal balances as far as melatonin is concerned. All right, the pancreas. Okay, so this is a big organ. The pancreas we're going to spend quite a bit of time talking about it in this unit, especially with regards to diabetes, a condition that a lot of us should already be aware of and know of. Um, but we're also going to talk about it in our next unit, digestive system, because interestingly enough, the pancreas is one of the unique organs that is both exocrine and endocrine. So it's involved in both areas of the body. So that's really something special for with regards to this. On the endocrine side of things, its entire purpose is maintaining blood sugar. You want to make sure your blood sugar levels are normal. These numbers have actually been adjusted relatively recently, but as of now, the safe levels is anywhere between 70 to 110. This number here is like, it's your unit, milligrams per deciliter. So you have special cells found on the pancreas. We don't need to worry too much about the cells, but they're called acinar cells and the islet of Langerhans. The acinar cells are going to be more involved with your exocrine function. Remember, exocrine, as the bell work was posted quite some time ago, uh, exocrine is more involved with secreting products out of the blood. You use special ducts to secrete it directly into an organ. So in this case, it would be directly into the small intestine. These are going to be all these digestive enzymes. Whereas with the islet cells, this is going to be more of the endocrine purpose. So this is really where things start to get more interesting. Okay, so our final thing today, just to keep it a little quick today, are alpha cells. These are going to be special cells found in the pancreas, those islet of Langerhans. We do need to know alpha and beta. So I'm just going to go ahead and underline alpha cells and beta cells. The alpha cells are going to secrete a special hormone known as glucagon. Glucagon, its entire purpose is to raise blood sugar. So glucagon increases blood sugar. That's an ugly arrow if I've ever seen one. Let's try that again with a little bit more stability. A little better. Glucagon raises blood sugar. So when would glucagon secrete on a normal day-to-day basis? Let's say it is 11:11 right now. Let's say you just woke up. The last time you ate a meal was, I don't know, 7 p.m. last night. Well, that's a long period of time. More than 12 hours has passed. So your body, even though you were probably sleeping for a lot of that period of time and you were on low energy, your body still needs energy to survive. Every single organ, every single cell, etc. So your body can secrete glucagon and it basically activates the stored energy that you have. What is the stored energy? Well, it's going to be carbs, right? All that glycogen that we store in our liver. If you run out of stored carbs, your body's going to turn into fat. We all have body fat on us, some of us more than others, right? And then in extreme scenarios, if your body still needs energy, it'll break down protein and it actually catabolize the protein so that you can sustain yourself from it. Now, the beta cells, on the other hand, their job is going to be a little bit more different. Beta cells are going to be responsible for secreting a hormone that a lot of us are very well aware of, insulin. Insulin, the job of insulin is to lower blood sugar. So when on a day-to-day basis is insulin part of our day-to-day lives? Eating. Anytime you eat something, it does not have to be necessarily like a very sweet food, but anytime you eat anything, your blood sugar spikes, it goes up. Insulin helps to regulate your blood sugar and lower it back down. So after eating, so post eating, you're supposed to see this high rise of insulin for a period of time until your body can kind of regulate itself. Last but not least, you'll notice that there's an extra set of cells here called these delta cells. I don't worry too much about them. They secrete a hormone called somatostatin. The whole purpose of somatostatin is to inhibit glucagon. So it tells glucagon, pause, like a stop sign. It just says, hey, we've had enough. We don't have to continue raising our blood sugar. It is definitely important. But for where we're at, I'm perfectly fine with this. All right. So that's where we're going to finish for today. Just a quick short video, and we'll continue forward. Not too much left over with regards to our content. Right, thanks, and have a good one.